Okay, this is Physics 2211, Lab 5. I'm Alexis Robinson. For table of contents, we have the intro, principles, tracker, glow script, compare, and discuss. The goal of this lab is to predict how a slinky falls and understand how its surroundings affect it. So I used tracker to analyze the video and glow script to simulate what was happening in the video. And we were supposed to determine the behavior of the bottom of the slinky during the drop. And from the data that I collected, the slinky bottom stays stationary until the entire slinky collapses and then it all hits the ground together. The assumptions made in this lab were that air resistance does exist. We did put it into glow script, and that the tracker point was like perfectly in the slinky bottom center of mass. The system is the slinky and the surroundings was the earth. The principles used were Newton's second law, which is F net equals ma, and then you can see it exhibited in this photo. We also used drag force, which is the air resistance slows falling motion, and then this is the formula for it. And gravitational and slinky force, in which each coil experiences gravity pulling downwards. So the force of gravity was negative mg, and then the force of the slinky was positive mg. So they like act opposite of each other. For my tracker, these were my results. It's a little wonky here, but the overall structure you can see. The mass was 0.218 kilograms. The height was 1.75 meters. The initial position was this, and then the initial velocity was 0 since in the beginning it wasn't moving. Here's all of my glow script code. Here is my mass and the simulation. And then the where everything actually went down was here. The iteration. And then I tried really hard to get Excel to put all of this data into a graph, but it was just not working with me, so I have to compare them individually. Overall, they do have similar structures. There's a little bit of whatever happening in the tracker. They were pretty similar, but of course, tracker has things going on in real life that the glow script can't account for. So my possible sources of error were that the code can't account for the small outside forces that we didn't physically put in, and the point of mass of the tracker is probably off a little bit. Does the bottom of your model slinky stay stationary just like in the video, and why? Yes, it did. Because the forces at the bottom of the slinky cancel out, so like gravity's pulling down, and then the slinky was pulling up like with the tension force. And then what if we attach a weight to the bottom? This depends on the length and the tension force of the slinky. If they're big enough to account for it, it'll still stay stationary. And yeah, that's my lab 5.